So in this video, we're going to look at a problem like the last one on the Unit 3 Quiz 1. And after watching this video, you can try that problem again and then resubmit because a lot of students struggled with this problem. So this problem gives you a list of characteristics and they asked you to graph the function that fits these characteristics. So just know that your graph can be different than my graph. It just has to have all of these features, but I don't know every point on this graph. So the height at some places is going to be different on my graph than someone else's graph that does this. The main thing is it has to fit these characteristics. So the first thing is they talk about is the vertical asymptote is x equals 5, and the domain is from -infinity to 5 to 5 to infinity. So to mark the vertical asymptote at x equals 5, you want to draw like a dotted line, and that indicates that your curve isn't going to cross this line. Okay, and it's not part of that domain. Now, this domain is telling me that everywhere else my function is continuous, and so my curve is going to hit every other x value on this graph. Now, the limit as x approaches -infinity of f of x equals 2, what that means is as I go to x values that are more and more negative towards -infinity, my y value is going to approach 2. So what you do usually for this is that you draw like a horizontal asymptote, a dotted line, just on this left side of your graph to indicate your curve is either going to go like approach this below it or above it and go along this curve as it goes out towards -infinity for the x values. The limit as x approaches infinity of f of x equals -4 is the same idea, but it's as x goes to positive infinity, so this way, my y value is going to go to -4. And so again, my curve is either going to be above this or below it and approach this y value. The next thing are the points, and these are usually the most important part and kind of the easiest way to get started with this. So we're going to plot these points on our graph. This is again my x, y, x, y, x, y. So I'm going to plot -5, 4, 0, 6, and 8, -8. And so the main thing is my curve has to hit all of these points. If it doesn't, your curve is not correct. It doesn't meet the characteristics of this graph. So that's a good place to start, like plotting those points in the asymptotes. And then from there, we need to figure out where my function is increasing or decreasing based on the derivative, the first derivative, so these two lines. And then where it's concave up and concave down based on these two lines. And sorry, I erased part. This should be 5 to 8. Okay, so the best way to figure that out is to draw a sign chart for the first derivative and for the second derivative. So for the sign chart, we're going to put the x values for where my derivative is changing. So we know that the derivative is greater than 0. So again, this means it's positive from -infinity to 2 and 8 to infinity. And then it's less than 0 or negative from 2 to 5 and 5 to 8. So what that means is I want to put the x values of 2, 5, and 8 on this number line, and I'm going to have it match up with my graph to kind of help. So I have 2, 5, which is where that vertical asymptote is, and 8. Okay. And just keep in mind that this is where the vertical asymptote is. So what we're going to do is we're going to put like positive, negative for the derivative and then indicate what f is doing. So my derivative is positive from -infinity to 2, which means this whole entire interval is increasing. From 2 to 5, we said it's negative, so it's going to be decreasing, which makes x equals to a max. Because again, we know my function is continuous everywhere except at x equals -5. So because the derivative changes from positive to negative, it's going to be 0 at 2, and it's going to change and be a max. And then from 5 to 8, we know the derivative is positive. So it's increasing. And then from 8 to infinity, we know that it's negative and decreasing. So vertical asymptote is not a max or a min, but at x equals 8, we know it's increasing and decreasing. So that's going to be a max, again, because that's part of our domain. So that helps me figure out where it's increasing, decreasing, the max and the min. Then the second derivative is going to tell me concavity. So again, we're going to look at the values where it changes and put those on our number line. So we can see it changes at -5, which on my graph would be here. -5. At 5 is the next one. So that's here. And then at 10. So over here. Only 10 is like there on my graph. So the second derivative is greater than 0, which means it's positive from negative infinity to -5. So it's concave up. And from 5 to 10, it's positive. So it's concave up. From -5 to 5, it's negative. So it's concave down. So this is the point of inflection. And from at 5, this is a vertical asymptote. So it's not a point of inflection. It is where it changes concavity, but because it's not a point on the graph, it's not a point of inflection. And then from 10 to infinity, it's negative, it's less than 0. So it's concave down, and then this would be another point of inflection. So what I need to make sure is that on these intervals where I say that my graph is increasing and decreasing on these intervals, and concave up and concave down. So we're going to start on the left. We know from the left that it's increasing and concave up until I get to -5. That's the first part. Now, because of this asymptote and this point up here, my graph needs to start above this asymptote and increasing to get to this point. It can't start down here because it's not allowed to cross this line as we go to negative infinity. So we're going to be here and increasing and concave up until I get to this -5. And at -5, I'm going to be concave down and still increasing until I get to 2. That's my next change at 2. So we're going to be concave down. So now it's curved down and increasing through this point until I get to 2. Okay, so this is going to be my max. That should be my highest point. Again, your y values can be different heights. Let's try to draw that a little bit smoother. And it's sometimes hard to tell. So make sure you label your point of inflections. And if it's hard to tell if it's up and down, like label that. Okay, so this is going to be my max. And then it says I am decreasing until 5. And I'm still staying concave down. So pretty much my curve is just going to go here and go down and be curved down the whole time and go along this vertical asymptote. So then on the right side of the asymptote, we know my function. Oh, sorry, I have this backwards. Let me fix this. This should be, my curve is from 5 to 8 negative, so it's still decreasing. And from 8 to infinity, it was positive, and so it's increasing. Sorry, I didn't look at this carefully. And so this is a min. Okay. So make sure you fix that. What that means is I'm going to go up here and I'm going to be decreasing until I get to x equals 8, which we know is this point. So until I get to this value, and then I'm going to increasing, and I'm going to be concave up that entire time until I get to 10. So I can put like some value at 10, we'll just say -6 here, because I know that my function is going to be coming down along this asymptote. Decreasing until I get to x equals 8. and then it's going to be increasing and still concave up. But at 10, I'm going to switch to then concave down, and I'm never going to cross this line. I'm going to go out towards that line towards positive infinity. And so again, this is my point of inflection. This is concave up, and then here it's down. So I have to make sure that my graph is increasing and decreasing where I said. So I said it was increasing until I got to 2, decreasing from 2 to 5, decreasing from 5 to 8, and then increasing, and make sure it matches up with what's here. And then I need to make sure that my concavity matches and that it's changing at these point of inflections at x equals -5 and x equals 10. Okay. So if you have questions, place them in the comments for the discussion and I'll answer them. And then if you want to try that quiz again, you're welcome to resubmit it.